Hello class, in today's video we are going to learn how to convert between grams and moles. This will serve as a review as we work our way towards solving molarity problems. So I do have a worksheet that goes along with this. We're going to work through problems 2, 4, and 9. In order to solve these problems, we will need a calculator and a periodic table. So the first thing before we can get into gram and mole problems is to review molar mass. So molar mass involves looking up the masses of each element on the periodic table and then multiplying by the subscripts for that particular element. So before I even go to the periodic table, I'm going to identify how many of each element I have. So in H3PO4, I have 3 H's, 1 phosphorus, and 4 oxygen. I'm going to multiply each of those numbers by the mass of the atom on the periodic table. So on my periodic table, I see hydrogen has a mass of 1.01, and you can write in units of grams per mole for now, 1.01 grams per mole. I see phosphorus is 30.97, grams per mole. And then oxygen is 16 grams per mole. I'm going to multiply across for each of those. And then after I multiply across, I'm going to add them all together for my final answer. So you might need your calculator. I'm going to turn mine on. I had 3 hydrogen. And notice I opened up parentheses here. 3 times 1.01, close parentheses. And then I'm going to add that to 1 phosphorus times 30.97, close parentheses, plus, open parentheses, 4 times 16. My final answer is 98 grams per mole. Now, on here, I didn't show all of that work. So if I wanted to break it down into smaller steps, I could. 3 times 1.01 is 3.03. 1 times 30.97 is still 30.97. And 16 times 4 is 48. If I add all of those together, I still get the same answer of 98.00 grams per mole. Now, this molar mass step is going to be very important because we're going to need that when we set up our gram and mole conversions in problems like number 4 and number 5. So first, let's identify what the question's asking for. Here it's asking for how many moles. And then our starting point, we are given 15 grams. Not just any 15 grams, 15 grams of lithium. So we're going to start with 15 grams of Li. And we have to refer back to dimensional analysis here. So I need to set up my fraction. Whatever my starting unit is, has to go on the bottom so that it will cancel out. So if I started in grams of lithium has to be on the bottom, and the unit I want has to go on top. So we're in moles of lithium. Now, I just need to figure out the molar mass of lithium from the periodic table. On the periodic table, I see lithium has a mass of 6.94. Now, as an aside, I want to talk about what those units mean. 6.94 grams per mole is the same thing as saying 6.94 grams for every 1 mole. The other way we can write a fraction representing this relationship is 1 mole over 6.94. grams. This particular fraction has grams on the bottom and allows us to convert between grams and moles. So I'm going to put that information on the bottom, 6.94 grams of lithium and 1 mole of lithium on top. Now I want you to pay attention very carefully here. The grams in this problem is specific to lithium. That means anytime we're converting between grams and moles, you're going to have a different number there that will relate back to the compound we're discussing. Whenever we're doing a gram and mole conversion, however, this first step, but this top of the fraction, the 1 mole is always going to be 1. Okay, so we have our setup. And we can even double check. I know when I multiply, grams of lithium will cancel out, and I'm going to be left in moles of lithium as my final answer. So I can go ahead and put my units down, moles of lithium. I also want to pay attention to significant figures. I have 2 significant figures to start this problem. So then let's go to our calculators. In the calculators, I had 15. I always multiply by the top, so open parentheses, times 1, divided by the bottom, 6.94, close parentheses. I get an answer of 2.16 and then a bunch of other decimals. Now, 2.16 would be 3 significant figures. So I would have to round this up to a 2. My final answer would be 2.2 moles of lithium, and that would account for my significant figures. The next problem, very similar setup. We're starting with 98.3 grams of aluminum hydroxide. Set up our fraction. Grams of aluminum hydroxide is on the bottom, and 1 mole of aluminum hydroxide will be on top. I have to figure out the molar mass for this one. So split it up here. Now we have to be careful because the 3 on the outside here really means we have 3 O's and 3 H's. So when we figure out our molar mass, it's going to be 1 aluminum times the mass of aluminum, which is 26.98, plus 3 times the mass of oxygen, which we covered before is 16 grams per mole, plus 3 times the mass of hydrogen, 1.01 grams per mole. We can go back in the calculator and set up our work just like that. 1 times 26.98. And notice I keep each section in parentheses, plus 3 times 16, close parentheses, plus 3 times 1.01, close parentheses. Here I get a mass of 78.01 grams per mole. So I can go back to my work. 78.01 grams goes on the bottom. And I can go through and solve my problem. Here I see 3 significant figures for my starting number. So my final answer will also have 3 significant figures. So 98.3, I think that's what we started with. Yep, 98.3 times, open parentheses, 1 divided by 78.01, close parentheses. And 3 significant figures would be 1.26. So my final answer would be 1.26 grams, or sorry, 1.26 moles, my bad. Got to double check those units. Moles of aluminum hydroxide. And you can double check the units. If we had grams of AlOH3, grams of AlOH3, we're left with moles of AlOH3 for our final answer. All right. One last little thing to say to help us set up here. In both of these problems, numbers 4 and 9, we used a fraction that looked like this, where grams was on the bottom and moles was on top. If you are starting in moles, you will have to go the opposite direction. If you're starting with moles for your first number, moles should be on the bottom, and then grams should be on top. Remember, in these problems, 1 always goes with mole, and then the molar mass always goes with the grams. Okay. In our next video, we'll go over some vocabulary dealing with molarity and dilutions, followed by another video with molarity calculations.